Here's an example of an alternating series, and then also the ratio test. Let me fix that so that it actually looks like a -1. I wasn't sure what it was before. You can tell by the amount of space that I've left here that this is going to be a pretty quick one. The alternating series test is pretty straightforward. The idea here is that if you have an infinite series and the terms on the signs on the individual terms are alternating plus minus or minus plus minus plus, as long as the magnitude, the size of the terms without the sign on it, just in magnitude, as long as that size is approaching 0, when we go to add these numbers up in an infinite series type of way, then we will get convergence. Because if the sizes of the numbers are getting smaller and smaller and going towards 0, and they're going plus minus, then what's happening is they're bouncing back and forth while they're zooming in on a particular value. So there's formal ways to write that up, and you can see that in the notes. What I'm going to do for this particular series is put it in a form where hopefully it's easier to see what's going on. So what I'm going to do here is I'm going to leave that front part alone. That's the term, that -1 to the n plus 1. That's the term that just turns on and off the sign, minus plus, or plus minus. And then I'm going to rewrite the interior of the larger part of the term as 1 minus 1 over n, because we want to ask the question, well, what's happening? We're going to label that the term a sub n. What is happening as n goes to infinity of the size of that term? Now, most of these formulas for convergence or ratio test, convergence test, or whatever, we're looking at the limit as n goes to infinity of the absolute value of something. We're looking at the size of the terms. So whether you call this whole thing a sub n or just this part of it a sub n doesn't really matter, because if we were to call the whole thing a sub n, well, the first thing we're going to do is put absolute value bars on it and lose the -1 term anyway. So just be specific about what you're calling what, and hopefully it won't make a difference. The alternating series test says this better be 0. If it is 0 and it's an alternating series, then you're going to get convergence. If this isn't 0, then you're adding up an infinite number of things that aren't getting closer and closer to 0 in size, and there's no way that can stay finite, and so you're going to get divergence. In our particular problem, that's the term we are taking the limit of. Now, there's a battle here between this number, the 1 over n, which wants to shrink to 0 as n goes to infinity, versus the fact that we have an exponent here, which is going to infinity itself. So this interior is getting closer and closer to 1 as n's going to infinity, but the exponent is going to infinity. So you would think something going to 1 raised to any power would be something approaching 1. But as you know, when limits are in play, weird things can happen. This may or may not be a limit you recognize. So I'm going to switch the screen. Here is our friend Wolfram Alpha, and I've asked for this limit as n goes to infinity of 1 minus 1 over n to the n. And that turns out to be 1 over e. Now, while we have this on the screen, just for fun, I'm going to make this a plus. Limit of 1 plus 1 over n as n to the n as n goes to infinity is e itself. So when limits are in play and you have something that looks like it might want to be a 1 or a 0, don't jump to conclusions, because it might not be the case. So let me switch back to this. Maybe I should have left myself a bit more room. This limit is 1 over e, which means in this summation we have an alternating series, plus minus, of numbers that are not shrinking to 0, but that are shrinking to very roughly 1/3. that series will diverge. Now, like I warn you very often when I'm doing these examples in video form, this right here is not how you submit an actual response. I'm just freewheeling here. This would be my scratch work that I've now used to discover that this diverges, but then I would go use this as a draft and write it a little bit better and maybe conclude with a full sentence. All right, for this next one, this is just going to be a full-blown ratio test question. Remember, the ratio test is where we build the recipe for this term at the n plus first spot divided by the recipe for the term as it is for the nth spot. See what happens to that ratio as n goes to infinity. So I'm going to build a sub n plus 1 for this particular beast, and this will be n plus 1 factorial instead of n factorial over, and then I'm going to draw this as a fraction in a fraction, n plus 1 over e. Now 2 times the quantity n plus 1 is 2n plus 2, so I'm just going to go ahead and write it out this way. And remember that this whole thing right here is a sub n itself. So then I need to build the ratio. That's why it's called the ratio test. A sub n plus 1 divided by a sub n. So here comes a sub n plus 1, which we've already constructed. There's a sub n plus 1 divided by a sub n. Well, dividing by a sub n is the same thing as multiplying by the reciprocal of this, right? So there's the n factorial underneath, and the n over e to the 2n up on top. And then I'm going to start clumping bits and pieces of this so that it's still algebraically correct, but I can see what might cancel. So for example, this n plus 1 factorial really wants to be close to this n factorial, so let's go ahead and do that. Everything's a product, so we can shuffle things around. Let's see, what else might like to be close to each other? The n to the 2n, which is currently in the numerator, might like to be close to the n plus 1 to the 2n plus 1. Sorry, 2n plus 2. So that there we can see some cancellation, and that leaves the e terms by themselves. Well, made that same mistake there. This division by e to that power flips it up into the numerator. So I will have e to the 2n plus 2 up top, and then this e to the 2n down below. Now let's watch some cancellation happen. N plus 1 factorial over n factorial. That's what cancels. So we leave behind just n plus 1. Here, what's going to happen here? Well, this is going to be the same, because really nothing's going to cancel. Right? N to the 2n, n to the 2n, n plus 1 to the 2n plus 2. There's not any easy cancellation there, so let's just leave it alone. And then over here, it looks like there's 2 more e's in the numerator than there are in the denominator. And now maybe we'll get a little cancellation, because this n plus 1 is going to take out one of the n plus 1's down there. And so altogether, we'll get that. It's still a mess, but it's enough to do the job. So I guess technically, well, maybe not. I was going to say we should go up here and put absolute value bars around the a sub n plus 1 over a sub n, but as long as we do it at some point, it doesn't matter. And here they come. And since everything here is positive, we don't really need the absolute value bars anyway. So the ratio test says, all right, fine. You build a sub n plus 1, you divided it by a sub n, you did all this to shake it out and simplify it. What are you going to do with it? Well, you're going to take the limit of that ratio as n goes to infinity. And if that ratio ends up being less than 1, then your series will converge. If it's bigger than 1, your series will diverge. And if it's exactly 1, you've learned nothing even after all that work. Well, here again, sloppy notation, but I'm looking at the limit as n goes to infinity of this mess right here. So e squared is just a constant. That could get factored out. So the action here is in the limit as n goes to infinity of n to the 2n over n plus 1 to the 2n plus 1. Now the plus 1 part of it we can kind of ignore. We've got basically the controlling n to the 2n over n to the 2n plus 1. This denominator is like the numerator except the degree, the power, is 1 higher. So as n goes to infinity, that denominator is going to win. We're looking at like n squared over n cubed, or n to the 50th over n to the 51st. Whatever it is, the denominator wins. That limit goes to 0. And so by the ratio test, let's say if I name this L, which happens in the ratio test, we have L less than 1, and so the series converges. And there, how about that? I almost wrote a complete sentence.